Welcome to a deep dive into the fascinating world of graph neural networks. We're going to unpack some cutting-edge research, fresh from the ICLR 2025 conference.
Okay.
A paper that could significantly impact how we understand and utilize AI.
It's always exciting to see new developments in this field.
Yeah.
And this paper is particularly interesting because it tackles a fundamental challenge that's been holding back the true potential of graph neural networks.
Okay, so for our listener, let's set the stage here.
Yeah.
We're talking about graph neural networks,
Right.
or GNNs. These are powerful tools for analyzing relationships.
Yes.
Anything from social connections to the way atoms are linked in a molecule.
Right.
What makes them so special?
Well, think of it this way.
Yeah.
Traditional neural networks are great at dealing with structured data, like images or text. But a lot of real-world information is relational.
Yeah.
It's about how things connect to each other.
Yeah.
GNNs excel at capturing these relationships and using them to make predictions or uncover patterns.
Right. It's like understanding the connections in a network.
Exactly.
Whether it's people on social media or the complex web of interactions within a biological system.
Yeah.
And one of the key concepts we need to grasp is this idea of an attention mechanism.
Right.
Can you break that down for us?
Absolutely.
Okay.
The attention mechanism in GNNs is like giving the network a way to focus on the most important connections in the data. Just like we might pay more attention to certain people in a room, depending on the conversation.
Okay.
Attentive GNNs learn to prioritize which connections are most relevant for a given task.
So it's about selectively weighting the importance of different connections.
Exactly.
That makes sense.
Yep.
But it sounds like there's a catch.
Yeah.
You mentioned that this paper tackles a challenge in this area. What's the problem that researchers have been grappling with?
The challenge lies in effectively scoring.
Okay.
The importance of neighboring nodes.
Okay.
This scoring function is crucial because it determines how much weight the GNN gives to different connections when making predictions. But finding the right scoring function has been tricky.
I see. So it's not just about having an attention mechanism.
Right.
It's about making sure that mechanism is as accurate and efficient as possible.
Exactly.
What have been some of the previous attempts to address this scoring challenge?
There's been a focus on the idea of static versus dynamic attention.
Okay.
Static attention assigns fixed weights to connections, while dynamic attention allows the weights to adjust based on the context.
Okay.
While dynamic attention was a step in the right direction, it's still too simplistic.
Right.
We need a more nuanced way to measure and optimize these scoring functions.
Okay, so the old ways of thinking about attention aren't quite cutting it.
Right.
That's where this new research comes in, right?
Exactly.
They're proposing a fresh approach to this whole scoring problem.
That's right.
Okay.
The paper we're diving into today introduces a new measurement called maximum ranking distance, or MRD.
All right.
In simple terms. MRD tells us how good a scoring function is at ranking the importance of nodes.
Okay.
The lower the MRD, the better the ranking and the more accurate the GNN becomes.
That's a really intuitive way to think about it.
Yeah.
So this MRD measurement gives us a yardstick to compare different scoring functions.
Right.
What did they find when they applied this measurement to existing attention mechanisms?
They analyzed three main types of attention mechanisms. First, there's linear transformation-based attention, which is the most common type.
Okay.
However, it turns out that this approach has a limited MRD.
Right.
Meaning it hits a ceiling in its ability to rank nodes effectively.
Okay.
Then there's MLP-based attention, which uses multi-layer perceptrons and offers better MRD. But even MLPs are constrained by practical limitations. You can't make them infinitely complex.
So both of these common approaches have limitations when it comes to accurately ranking the importance of nodes.
Yeah.
It sounds like we're building up to something pretty revolutionary here.
Yeah. Wow.
What's the groundbreaking solution this paper proposes?
Well, they introduce a new attention mechanism called KAA, or Kolmogorov-Arnold attention.
Okay.
And this is where things get really interesting.
Right.
KAA leverages the power of the Kolmogorov-Arnold network, or GAN, a type of neural network that's been making waves in the AI world.
Okay, I have to admit, Kolmogorov-Arnold That sounds pretty intimidating.
I know it's a mouthful.
Yeah. Can you demystify that for us a bit?
Sure. Okay. What's unique about KN is its ability to approximate any continuous function with a high degree of accuracy.
Yay.
This makes it incredibly versatile and powerful, especially for tasks that involve mapping multiple inputs to a single output.
And how does that tie back to the scoring function in GNNs?
That's the brilliance of this research.
Okay.
They recognize that scoring node importance is very similar to those tasks KNA excels at.
Yeah.
You're essentially taking many node features as input and using them to generate a single importance score as output. By employing CAN within the attention mechanism, KAA achieves something remarkable.
Okay.
A near-infinite MRD.
Hold on, near-infinite MRD?
Yeah.
Does that mean it can rank nodes with almost perfect accuracy?
That's the implication.
Wow.
And it's a significant leap forward. It does seem almost too good to be true, doesn't it?
Well, that's what I was just about to ask you about.
Yeah.
This can't all be theoretical, right?
Right.
They actually put KAA to the test.
They did, and they tested it across a variety of tasks to see how it would perform in different scenarios.
Okay.
One of the tasks they looked at was node classification.
Right.
This is where you're trying to categorize things within a network. For example, you might want to classify research papers by topic or products by category.
Okay.
And KAA consistently outperformed the original models.
Wow.
On a variety of benchmark data sets for node classification.
That's impressive. So it's not just a good idea on paper.
Right.
It actually delivers in a practical setting.
Yeah.
What other tasks did they test it on?
They also explored link prediction.
Okay.
Which is essentially about predicting connections between nodes.
Right.
This has a lot of applications like recommending friends on social media or even predicting protein interactions in biological systems.
Yeah.
And again, KAA showed significant improvements over existing methods.
So it's crushing it on individual nodes and connections.
Yes.
But what about analyzing entire networks?
Right.
That seems like a whole other level of complexity.
You're right. Analyzing complete networks is much more challenging.
Okay.
But this is where KAA really shines.
Right.
They used it for graph classification and regression tasks.
Which involve analyzing entire networks to predict properties.
Right.
Like predicting the properties of molecules based on their structure, or understanding the flow of information in a social network.
Okay.
And the results were remarkable.
All right, I'm on the edge of my seat here.
Yeah.
Give me the highlights.
Okay.
How much of an improvement are we talking about?
In some cases, they saw performance boosts of over 20% compared to existing models.
Wow.
This is a huge leap forward and suggests that KAA could truly unlock the full potential of graph neural networks.
That's pretty mind-blowing. I can see why you're so enthusiastic about this research.
Yeah, it's really cool.
But I have to ask, are there any potential downsides or limitations to using KAA? Does this new approach come with any trade-offs?
That's a great question.
Yeah.
The paper does acknowledge that it's still early days for KAA.
Okay.
More research is needed to fully understand its capabilities and limitations.
Right.
One potential concern is that KNN itself can be computationally expensive to train. So there might be some practical challenges in applying it to very large data sets.
Yeah, that's something to keep in mind.
Okay.
But overall, I think the benefits outweigh the potential drawbacks.
I think so.
Yeah.
This research tackles a fundamental bottleneck in GNNs.
It does.
The fact that they've shown such impressive results with KAA is incredibly promising.
It is, yeah.
And it's not just about improving GNN performance.
Right.
This could have a ripple effect across the entire field of AI.
Yeah, definitely.
That's what I find so fascinating about these kinds of breakthroughs. They often open up new avenues of research and inspire innovation in unexpected ways.
Yeah, for sure.
What are some of the potential ripple effects you foresee?
Well, if KAA proves to be as effective as these initial results suggest,
Right.
it could have a major impact on how we develop and use AI in the future.
Yeah.
For example, we might see new and more sophisticated applications of GNNs in areas like drug discovery,
Right.
personalized medicine, and material science.
It's exciting to think about the possibilities.
Yeah.
So for our listener,
Right.
let's bring it all back to the big picture.
Okay.
What's the key takeaway from this deep dive into the world of KAA and graph neural networks?
The key takeaway is that this research represents a significant step forward in addressing a fundamental challenge
Okay.
that's been holding back the progress of GNNs.
Mm-hmm.
The traditional scoring functions we've been using have limitations.
Right.
And KAA, with its clever use of the Kolmogorov-Arnold network,
Yeah.
offers a powerful and elegant solution.
And it's not just a theoretical advancement.
Right.
The researchers have demonstrated that KAA leads to significant performance gains on real-world tasks.
Yeah.
This is a development with the potential to reshape how we use AI to tackle complex problems across various domains.
I completely agree.
Yeah.
This research has the potential to revolutionize how we approach tasks like drug discovery, social network analysis, and even understanding the complexities of the human brain.
Okay, listener, it's time for us to wrap up this deep dive.
Okay.
But before we go,
Yeah.
we want to leave you with a thought-provoking question to ponder.
Yeah.
Given the potential of this technology, what impact could these advancements in GNNs have on your field of work or your area of interest?
How might this new tool reshape the way we solve problems and make decisions in the future?
The possibilities are truly immense.
Yeah, they are.
And we're excited to see how this technology unfolds and what innovations it inspires.
Yeah, me too.
Thanks for joining us on this journey into the exciting world of graph neural networks and the power of KAA.
Thanks for having me.
It's amazing to think about the potential ripple effects of this research. I'm particularly fascinated by the implications for drug discovery. Imagine being able to use these enhanced GNNs to model the interactions between molecules with much greater precision.
Yeah, it's an incredibly exciting prospect. With improved accuracy, we could potentially accelerate the development of new drugs and therapies for a wide range of diseases. We might even be able to personalize treatments based on an individual's unique genetic makeup and the specific characteristics of their condition.
Yeah, it's incredible. It's like taking personalized medicine to a whole new level.
Mm-hmm.
And what about social networks? We're already using GNNs to analyze how information spreads and how communities form online. Could KAA take those analyses to a deeper level?
Absolutely. With KAA, we might be able to develop much more sophisticated models of social dynamics. We could gain a better understanding of how opinions form, how trends emerge, and even how to identify and mitigate the spread of misinformation or harmful content.
It's a bit daunting to think about the potential for both positive and negative applications of this technology. We're talking about potentially predicting and influencing human behavior on a massive scale.
Right. It's certainly a powerful tool, and it underscores the importance of ethical considerations in AI development. We need to ensure that these advancements are used responsibly and for the benefit of society.
That's a crucial point. It's not just about the technical advancements, it's about how we use those advancements and the potential impact they have on individuals and communities.
Exactly. As researchers and developers, we have a responsibility to consider the ethical implications of our work and to engage in open dialogue about how to harness the power of AI for good.
And it's not just on the researchers and developers. It's a conversation we all need to be a part of, policymakers, industry leaders, and everyday citizens. We need to work together to shape the future of AI in a way that benefits humanity as a whole.
I couldn't agree more. It's a collective responsibility to ensure that AI is used to address society's most pressing challenges and to create a more equitable and sustainable future for everyone.
Well said, listener. We've only scratched the surface of what's possible with graph neural networks and the groundbreaking potential of KAA. It's a rapidly evolving field, and we can only imagine what the future holds.
It's an exciting time to be involved in AI research, and we can't wait to see what breakthroughs emerge in the years to come.
And who knows, maybe some of those breakthroughs will come from you, listener. We encourage you to keep exploring, keep learning, and keep pushing the boundaries of what's possible. Maybe one day we'll be doing a deep dive into your research.
That's a great point. We're always eager to learn about new developments and innovative applications of AI.
So to wrap things up, we want to thank you for joining us on this deep dive into the world of graph neural networks and the fascinating potential of KA. We hope you've enjoyed the journey and that you're leaving with a sense of wonder and a thirst for more knowledge.
Until next time, stay curious and keep diving deep.